Today we are locating and comparing irrational numbers. When I say locate, that means that you can place it on a number line. And when I say compare, that means when given an irrational number and some other number, you can say which one is bigger. Let's review what irrational numbers are. Irrational numbers are numbers that cannot be written as a fraction, whereas rational means it can be written as a fraction. With square roots, some of them are rational and some of them are irrational. If you took the square root of 4, that number is rational because it is just 2, and 2 can be written as a fraction. It also terminates, that's how you can tell. If you do the square root of 5, then you end up with a much longer decimal. I can actually get more digits on this website. You end up with this really long decimal, and the ... right there means it goes on forever, and it does not repeat any digits. So to tell if it's irrational, remember it goes on forever and it doesn't end up repeating some numbers over and over again. So this is irrational. Basically, the pattern that we find is that if we have a square root where it's the square root of a perfect square, like 64, it's going to end up being rational because it simplifies to an integer. If we have a square root that is any other number, like 112 is not a perfect square, then it's going to end up being irrational. It goes on forever and it does not repeat. So let's go over here, and the irrational numbers you're going to deal with are frequently square roots and also pi. You should know what pi is. It's about 3.141. Let's go ahead and see some types of problems that we would normally do. The first one is actually pretty simple and easy. You're going to name the point on the number line that could represent each irrational number. I'd recommend looking at the points that you have to begin with. So A is going to be close to 5, B is close to 6, and C is about 7.5. So we don't have to get super precise on figuring out what points these square roots are going to be because all of our points are pretty far apart. So the square root of 24, I know it's close to the square root of 25. The square root of 25 is 5, so 24 will be just a little bit less than 5, and that tells me that it's A. Notice I didn't go as far as to approximate to the nearest tenth because I didn't need to distinguish it from the other points. Be smart about the work that you do and do just what you have to on this one. For the square root of 39, I know it's a little bit bigger than the square root of 36, so it's going to be a little bit bigger than 6. That tells me that it is point B. And then for the square root of 56, it's, I know 49 is close to there, so it'll be bigger than 7, and then it should be less than 8, and it is because the square root that becomes 8 is the square root of 64. And it looks like it's about right in between, so that does tell me that yes, it is C, even though you could have gotten that by the process of elimination. We're going to go ahead and do something a little harder. Now, instead of giving us the points, this question asks us to put the points on the graph. On this one, you are going to need to approximate it pretty close to the nearest tenth. For the square root of 2, I'm going to find a perfect square above and below. And I show you exactly how to do this in another video, so be sure to check that one out if you're confused. A square root that I know that's close to 2 is the square root of 1, and the square root of 1 is 1. Then it's automatically between 1 and 2, and 2 squared is 4, so that's the square root it's between. I know because it's between 1 and 2 that it will start with 1 point something. Now let's go ahead and see how far away it is from each of these. It's just 1 away from 1, and it's 2 away from 4. So it is about 1/3 of the way, or 1.3, between 1 and 2. Now, the square root of 2, this is the one time this doesn't end up being very accurate. The square root of 2 is actually 1.4, but if you got 1.3 as your approximation, that will work pretty well on our graph. So now let's go ahead and graph it on here. It's going to be point A. When you put it on a number line, please be careful and check how it's labeled. I noticed that it's 1.0 and 1.5. Some people will be tempted to think this is 1 and this is 2, so they'd put it there. That's actually wrong. It's 1.3, so it's going to be just a little more than halfway between 1 and 1.5. So there's my A. Now let's go ahead and do point B. I'm going to change colors for this one so you can tell what's going on. The square root of 17, we're going to put our perfect squares. I know the square root of 16 is very close, and the square root of 16 simplifies down to 4. So I know that square root of 17 will be between 4 and 5 squared is 25. So it should automatically start 4 point something, and I'm going to say it's super duper close. So we're going to say it's 4.1 because that's pretty close to 4. And you notice how it's 1 away from 16 and then 1, 2, 3, 4, 5, 6, 7, 8 away from 25. So yeah, it makes sense that it's 4.1. Let's go ahead and put our B on at 4.1. And it's got to be 1/5 of the way because it's 4.0 to 4.5. So I'm going to put my point B right there. Okay. For the other points, go ahead and try those out and approximate them. I'm going to show you my answers. Okay, for the square root of 11, I got about 3.3. So I'm going to graph point C. Oh, I should change colors, huh? Point C right there. That's my C. Okay, let's change again. The square root of 8 is going to be very close to 3, so I'm going to say it's 2.8. So let's go ahead and put the square root of 8 right there. And then for the square root of 5, it is between 2 and 3. It's about 2.2. So there's my point E. Now, I'm going to go ahead and write down what all of these numbers were and see if you notice anything. A is the square root of 2, B is the square root of 17, E is the square root of 5, D is the square root of 8, and C is the square root of 11. What do you notice as you look at these numbers? You should notice that they're going up, and the square roots, the number inside, if it is bigger, then the square root of that number will also be bigger. Okay, we have one more thing to try out. Now this is where we just are going to pick which number is bigger. Just like example 1, you should do the least amount of work it takes to figure out which number is bigger. So let's go over here and do A. I need to find out if the square root of 50 is bigger or smaller than 6.8. And it's very, very close to the square root of 49. It's actually bigger than that, and that's 7. Since it's bigger than 7 and 7 is bigger than 6.8, I'm going to say it's greater than. Remember that the big side is always pointing to the bigger number. Now, just like we learned up above, the bigger square root will be the bigger number, so I'm just going to do that. Easy. Now this one, you have a fraction that might be a little hard for you to figure out as a fraction, so I would write this as a decimal. It's 4.5. And the square root of 17, it is going to be a little bit bigger than 4, but I wouldn't say, let's look. It is very, very close to 4. It's not halfway in between 16 and 25, so we're going to say that 9/2 is bigger. And then over here, the square root of 81, you should know, that's 9. Is 9 bigger than 8.1? Yes, it is. And then for this one, the square root of 99 is going to be very, very, very close to 10. So 27 thirds would be 9, so this is 9 1/3, and 9 1/3 is less than 10, so it looks like that. Okay, good luck on your assignment today.